Hi class, today's lesson will come from chapter 26. We're going to work on problem 5B. You should be able to see now chapter 26, problem 5B. And what we're doing in chapter 26 is we're evaluating capital investments that we're thinking that we might invest in. And you can do that through using present value techniques. And in this problem, we're going to use present value techniques to evaluate each one of these investments. The investment committee of Auntie M's Restaurants is evaluating 2 restaurant sites. The sites have different useful lives, but each requires an investment of $900,000. The estimated net cash flows from each of the sites are as follows. Since they've just given you the net cash flows, we're going to be using present value analysis to evaluate each one of these restaurants. The committee has selected a rate of 20% for purpose of present value analysis. That's very important. It's 20%. So we're going to be using 20% as our present value analysis. It also estimates that the residual value at the end of each restaurant's useful life is going to be 0. But at the end of the 4th year, Wichita's residual value would be $500,000. So they've given you 2 different tables this time. They've given you the present value of a dollar table and present value of annuity table. Be careful and read your instructions carefully as to which table that they want you to use. In requirement number 1, it says for each site, compute the net present value to use the present value of the annuity table. They want you to ignore unequal useful lives of the projects. So we're just going to use the useful life of each one of the projects separately, and we are using the present value of the annuity table. An annuity is a series of equal cash flows. Since both of these assets had net cash flows that were equal in amount, you could have just used the annuity table, especially in the first problem. That's what they're telling you to use, but they're telling you also to ignore the unequal useful lives in this first problem. Notice that Wichita has a 6-year life. Topeka has a 4-year life. So they've got unequal useful lives, which could affect the present value analysis. So read your directions carefully. Use the table that they direct you to use when you're calculating these problems. So since Wichita, we're going to start with that first, has cash flows expected of $310,000 for 6 whole years. That's going to be the life of this asset. When we are using the present value of the annuity table, the only thing we have to know is what the rate is going to be that management is wanting us to use. And we have to use the annuity table. This is the annuity table right here. This is the present value of the dollar table right here. We are using this table only in the first part of the calculations because they told you to use this table. It's 20%. That was the selected rate for net present value analysis. For the first restaurant, which is the Wichita restaurant, since they have 6 years of useful life, we're going to go down 6 years and across to 20%. Do you see this table value here of 3.326? We're going to use this in our present value analysis. Because this was an annuity and we're using the annuity table, we don't have to use each year separately. We simply take the number of years in the life of the asset and the table value amount and multiply it one time by the equal annual cash flow. So for Wichita, I want to find the total present value. And what I have to do is I have to take the amount of the annuity, which is 310,000, and I'm going to multiply that by the 20% rate at 6 years, because there was a 6-year useful life with this asset, and I'm going to multiply it by 3.326, and that will give me my present value amount. So when you're using the annuity table, you simply multiply the annuity amount for 1 year times the table value amount for the useful life, which was 6 years at 20%, which is 3.326. When you multiply those out, it'll give you the present value of the Wichita restaurant. We're going to take the amount of the cost of the Wichita restaurant, which was given. Both of these restaurants have a initial cost or an investment we're going to have to make of 900,000. So the amount invested is 900,000. The difference between the present value and the amount invested will give you the net present value amount. So for Wichita, the net present value amount is $131,060. We're going to compare that with what happens to Topeka. Notice Topeka has a shorter life, and notice that they also have more of a cash flow each year. Again, the cash flows are equal, so we can use the annuity table. The rate of interest was 20%, but this time we're going to go to 4 years because this asset has a 4-year estimated useful life. So 400,000 times 2.589 is how we get the present value amount for the Topeka restaurant. We're going to compare that to what it cost us, and the difference is the net present value. Notice the net present value for Topeka is larger. So if we were just evaluating based on number one, we would say Topeka is the type of asset that we would use. Now in part number 2, we're computing net present value, assuming that Wichita is going to be adjusted to a 4-year life. What happens with Wichita is that we're going to have to find the present value of the annuity amount for each of the 4 years, and then we're going to also have to calculate the present value for the residual value that's left over at the end of the 4th year. So all this information is coming from what was given. At the end of the 4th year, Wichita's residual value is going to be 500,000. So there's an extra cash flow that we're going to consider for Wichita, in this case, at the end of year 4. Now, notice that in part 2, they've told you that you're going to use the present value of the dollar table. When we're using the present value of the dollar table, we have to multiply each year's cash flow by the table value amount. So we're going to start with Wichita. We're going to start with year number 1. And in year number 1, the cash flow was 310,000. 310,000 is going to be multiplied by 8.33 to get the present value at the end of year 1. At the end of year 2, we're going to take the 310,000 for year 2 and multiply it by 0.694. And that will give us the present value for year 2. For year 3, we're going to take the net cash flow, which is 310,000. We're going to multiply it by 0.579 in year 3. And that's going to give us the present value in year 3. And in year 4, we're going to take the present value, the cash flow, which is 310,000. We're going to multiply that by the table value amount for year 4, which is 0.482, and that will give you the present value for the cash flow in year 4. Now notice I've added one more line here, and I've got year 4 out here because at the end of year 4, we also had, or we're expecting, a residual value which is worth 500,000. So we think that we could sell this truck and it would be actually worth 500,000. So we need to, or it's not a truck, is it? It's a restaurant that we're talking about here. But I think in your problem, you're going to be using a truck. But anyway, Wichita's residual value is going to be 500,000. So we have to use this 500,000 and apply a present value to this amount, because that means something to us. If we sold the restaurant, we ought to be able to get $500,000 in cash for it. So this 500,000 would be multiplied by, at the end of year 4, because this happened at the end of year 4, it would be 0.482. So this is reflecting the residual value at the end of year 4 multiplied by the present value factor for 4 years at 20%. Once you have determined your present values, you're going to total them up. Then you're going to put down the initial amount of the investment, which we thought the cost of this investment was going to be 900,000. The difference between these is the net present value amount. For Topeka, it only had a 4-year life. There was no residual value at the end of this life that we had to take into consideration. So you simply multiply each cash flow times the table value amount in each year. So the year 1 is 400,000 times 0.833 will give you the present value of year 1, which is 333,200. To get the present value in year 2, we'll take 400,000 and multiply it by 6.94. And that will give you the present value in year 2. In year 3, we'll take the 400,000 and multiply it by 0.579. And that will give you the table value for year 3. And in year 4, we're going to take the 400,000 and multiply it by 4.82 or 0.482, excuse me. And that will give you the present value for it. Notice there was no residual value at the end of this year. These are the cash flows. You add up the present values for the cash flows. The total present value is $1,035,200. Then we're going to subtract out what it's going to cost us, and we have an amount in excess, or the net present value, at $135,200. Now, what this tells us is that Wichita would have the higher amount of net present value in part 2 when we shaved the useful life to 4 years, and we ended up with a residual value that added to that net cash flows. It pushed us up. So we would choose Wichita for the second investment answer that we would want to invest in for our company, because we think it has the potential to make us more money in the future. And in part 3, they've just restated that. They said the net present value of the 2 sites over equal lives indicates that Wichita, this was the equal lives where we switched it to 4 years, has a higher net present value and would be the superior investment. Excuse me. So again, we are simply evaluating investments using present value analysis. So I'm going to stop sharing here, and we'll see you again next time. Bye-bye.